Hey math students, in this video we're going to be going over some things that we learned in previous math classes because we need that information to be applied into new ways as we go into this unit. Specifically, we're going to be looking at domain and range. So here's the mathematical definition for domain. It's the complete set of possible values of the independent or x variables. I really stress that possible values because another way of saying that is like, what works? What works when I plug it into the function? So what works for the function of to be plugged in for x? And then the range, the definition for range is the complete set of all possible resulting values of the dependent y values. So we need to substitute in that domain, and they're the corresponding output of y values. So let's look at some examples, and I think it will help clarify these definitions. So here I have a table of values. Table of values has an input and an output. So we want to look about the domain and the range for these input and output values. If I think back to that definition of domain, it's the list of all possible x values, or the x values that are working or defined in this function. So here I have my x values. They are already defined for me in this table. They are defined to be -2, -1, 0, 1, and 2. So guess what my domain is? It's the list of these independent numbers or independent values of x. Now the y's correspond to the range. So y's or outputs for the range, they are the corresponding outputs when we plug in a function or plug in a number. So we plugged in -2 to some unknown function, we don't know what it is, and we got out a -12. That -12 is the corresponding output for the input of -2. So -12 is a part of that range. So -12, same with -9, -6, -3, and 0. So it's important to remember that the domain is the list of all the numbers that work for x, and the range is the list of numbers that correspond to those x values, but they're the y values. So domain, x, range, y. So now let's look at a graph. This is a piece of a graph. Piece because we have stops here. And these arrows are really, really helpful for me because they are helping me identify both the domain and the range. So if we're thinking about domain, I'm remembering that to be the x values. I'm thinking about, okay, where is this graph or this function that gave me this graph? Does it work on the x values? So this function kind of starts down here, but its corresponding x value is this -5. And then this function continues, right? It can be -4, it can be -3, it can be a -2. And that function continues all the way up to where it stops at the corresponding x value of 3. So my function is defined to be in between -5 and 3. So we write that mathematically. One way of writing it is using an inequality. So x is in between. So that means the -5 has to be the smallest number. So I'll use my less than or equal to sign. And then the 3, that is the absolute biggest x value that this function could be. That's where it stopped. So x's actually have to be smaller than that 3. If you remember, the alligator eats the bigger number. So the alligator is eating the 3 because it's the biggest number. Okay, let's look at that same idea as it applies to the range, which is the y values. So here's my function. Where does that function start on the y values? It starts out over here at 3, and again, this function is working on the y values all the way up to where it ends at this 4. So for this guy, my range is from -3 all the way up until 4. And we're talking about the range now, so y's, and y is in between these numbers, so I'll use that same logic using my inequalities. Okay, so what if we have a normal linear function? Linear functions have arrows on them. It's not really shown here on my Desmos graph, but this arrow keeps going further and further and further all the way down to kind of that bottom left-hand corner. And then same thing in this right, it continues on that way. So domain, I'm looking at my x values. What can my x be? So I like to think about just regular numbers. What type of numbers do we have? Well, we have positive numbers. So in my x values, my x's are right here. Is my function showing on that side of the graph? Yeah, it's down here, but for sure, it's on the right-hand side of the graph where x's are positive. Now, does it show all of those numbers that are positive? Yeah, because remember, this arrow, it keeps going on and on and on forever, so it's always going to be positive. So I am now narrowing down to my domain can be all positive numbers. Okay, what about negative numbers? So now I'm going to think about the left-hand side of the graph. So here's the left-hand side. That split down the middle is my y-axis. And do I have a graph that goes to the left? Yeah. I have a graph that keeps going further and further. It's going like down to the left, but yeah, it's still going way to the left. And most importantly, it's crossing through the middle so it can be 0. So we've kind of covered all the numbers, negatives, 0, and positives. So that means that my domain is all real numbers. There's no number that I can think of that I cannot plug into this function. I can use a decimal. 3 times 0.2 minus 6. Yeah, I can totally do that. You'll get another decimal, but I can still absolutely do that. So domain is all real numbers. So then range, we're looking about the exact same way, but we're just now scanning on the y-axis. So here's where my y's are positive. It's up at the top. So do I see my function up here at the top? Yeah, it's like in the very far corner of my graph, but sure, absolutely. It keeps going up to the right, but up nonetheless, forever and ever and ever. So I have positive y's. Can I be 0? Can I have an x-intercept where y is 0? Yeah, it's defined right here. What about negative numbers? Yeah, I can see a whole bunch of those negative numbers. So same thing. The range is all real numbers as well. And my handwriting has never been great, but then get me writing on a computer and it goes even further downhill. So hopefully you can read that. So in this activity, you've recapped a couple of different vocabulary words: x-intercepts, y-intercepts, domain, and range. Here's all of that vocabulary, and the purpose of this is that now we're going to take all of that same vocabulary that you've previously studied with linear functions, and we're going to apply it to quadratic. So it was nice to do a little bit of review of things that you previously learned so that we can apply them as we move forward. So as always, if you have any questions, please let me know.